Welcome to a lesson on solving inequalities. Okay, I've got a joke for you. What did the green grape say to the purple grape? Man, quit holding your breath. Isn't that good? I appreciated that. I learned that this week. Okay, back to the business at hand. I would like to begin by showing you the similarities between equations and inequalities. You'll be happy to know they are very similar, with one caveat that we're going to see a little bit later. So let's say that we have these 2x plus 5 equals 17 and 2x plus 5 is less than 17. Very similar. We're going to solve the equation first. So I've drawn my wall. I need to remove the 5 because it's what's furthest from my variable. So the opposite is subtraction. Subtract 5 from both sides of the equation and you'll have 2x equals 12. To rid the x of the 2 that's being multiplied, I need to divide by 2 on both sides. And if I do that, I'll have x equals 6. Now when you graph x equals 6 on the number line, you'll find the exact answer is 6. 6 is the only number that will make the equation true if you were to substitute 6 back in place of x originally. 2 times 6 is 12, 12 plus 5 is 17. Now let's entertain the inequality on the right. Notice I've drawn my wall where the inequality is. I'm still going to find what is furthest from my x and remove it first. I'll be left with 2x is less than 12. And to remove the 2, you'll see I divide by 2 on both sides. So really the approach is exactly the same. And when I finish, I'll have x is less than 6. Notice it's not x equals 6. It's x is less than 6. So when we graph this, anything that's less than 6 is a solution. In other words, anything less than 6, if you plugged it in for x in the original inequality, would make it a true statement. So let's just pick a number. Let's pick maybe 5. If you were to insert 5 in place of x, 2 times 5 is 10, plus 5 is 15, and 15 truly is less than 17. But let's test 0. 0 times 2 is 0. 0 plus 5 is 5. 5 is less than 17. There are infinitely many solutions that will make this one true, contrasted to the 6 for the equation, which is the only number that will make that a true equation. But there are lots of choices, as long as the number you choose is less than 6. So we graph that. You'll notice I've shaded to the left of 6. That's to highlight any possible solution to this inequality. Shading is a big deal with inequalities because there are more than one right answer. So I want you to look at these comparisons. Here is the major difference with inequalities and equations. So if I had to compare 4 and 1, 4 is further to the right on the number line, so it has a greater value than 1. Well, let's start with 4 and 1 again, except this time let's double both numbers. So 4 times 2 is 8, 1 times 2 is 2. But you'll notice 8 is still greater than 2. So I still have the same symbol to compare, the left side to the right side. Let's start with 4 and 1 again. So this time, let's add 2 to both. 4 plus 2 is 6, 1 plus 2 is 3. The comparison has still not changed because 6 is greater than 3. Let's start with 4 and 1 again. 4 is still greater than 1. And let's subtract something from both of them. 4 minus 1 is 3. 1 minus 1 is 0. You'll notice that 3 is indeed greater than 0. All the comparisons thus far from the beginning of the 4 and the 1 has been greater than, and everything I've done, multiply by positive 2, add 2, subtract 1, everything has still given us the same comparison of greater than. What happens when we take 4 and 1 and multiply by negative 1? The result is negative 4 and negative 1. And now here's the difference. Negative 4 is not greater than negative 1. I cannot use the same symbol to compare. I now, to make a correct statement, have to make it less than. Negative 1 is further to the right on the number line than negative 4. So negative 4 is less than negative 1. Didn't happen when I multiplied by 2. It happened when I multiplied by negative 1. Let's do one more. If I start with 4 and 1, now 4 is greater than 1. But if I divide by negative half, and you could check that on your calculator to prove it right, 4 divided by negative half is going to give you negative 8. 1 divided by negative half will give you negative 2. Now negative 8 is not greater than negative 2. So I'll have to turn my inequality around and say less than. Negative 8 is less than negative 2. So the takeaway from this page hopefully is you'll realize when you multiply or divide by a negative number, you're going to have to flip the inequality so that it has a true statement. If you don't, then you've got an incorrect statement. Negative, when you multiply or divide, is the only time that you have to flip the inequality. So let's look at a few. 2x minus 3 is greater than negative 11. So we're going to draw our wall. We'll start by adding 3 to both sides. That gives us 2x left on the left and negative 8 on the right. Notice I'm still bringing down the greater than symbol. I have no reason to turn it. Now to finish this, I'm going to have to divide by a positive 2. Since I'm dividing by a positive 2, there's no reason to flip your inequality. So 2 divided by 2 leaves you with 1x. Bring the greater than symbol down. Negative 8 divided by 2 is negative 4. It doesn't matter what your answer is. It matters what operation you have to do to finish the problem. And if in that solving the inequality you have to multiply or divide by a negative number, flip the inequality to keep it a true statement. Second problem, 5 minus 8b is less than or equal to 21. Draw your wall. I need to isolate b, so to remove the 5, notice in front of the 5 there's no symbol. That means that 5 is positive. So 5 has been added to this problem. I'm going to subtract 5 from both sides of the inequality. What I'm left with on the left side is going to be negative 8b less than or equal to 16. Now to finish, I've got to remove the negative 8 and it's being multiplied to b, so I'm going to divide by negative 8 on both sides of the inequality, and this is the case we've been talking about. Negative 8 divided by negative 8 is a positive 1b, but since we've divided by negative 8, I'm going to have to flip my inequality to greater than or equal to so that it'll still maintain a true statement. 16 divided by 8 is negative 2. Now guys, I want to prove this to you. I want to check our answer. So I have to pick something. I'm going to go to the original inequality, 5 minus 8. I've taken the b out, and I'm ready to welcome a solution in place of that to see if it's true. Let's test 0, because I could have picked anything. My answer that I circled says anything greater than or equal to negative 2 will work. Now 0 is to the right of negative 2 on the number line, so it has a greater value. I always like to check 0 because I don't have to worry about signs if 0 is a solution. So let's see if 0 works. 5 minus, 8 times 0 becomes 0. So 5 minus 0 is just going to be 5 is less than or equal to 21, and since that's true, it checks. And I have flipped it adequately. I've done the right thing. Let's do another problem. It may have a multi-step. So it's solving an inequality still. Draw your wall. Now on the left side, I don't have anything to simplify, but on the right I'm going to do the distributive property. I've not changed my inequality. I'm going to leave it less than or equal to. So I have to distribute 2 by everything on the inside of the parentheses. 2 times 10 is 20. Notice there's no number with the x, so I understand there's a ghost 1 there. And then realize he's a negative 1x. So positive 2 times negative 1x leaves me with negative 2x. So now I get to solve for x. I have to remove the 20 and the negative 2, and I'm going to do them in 2 separate steps. I have to remove what's furthest from my x first. So I'm going to subtract 20 from both sides. 10 minus 20 is negative 10. Bring down my less than or equal symbol. And 20 minus 20 on that side goes to 0. All I have left on the right side is negative 2x. To remove the negative 2 from the x, I have to divide. Since it's being multiplied, I'm going to divide by negative 2 on both sides. At this point, I'm dividing by a negative, so that means I have to flip my inequality. Notice it's no longer less than or equal to, it's now greater than or equal to. And on the right side, it's a 5. So this says 5 is greater than or equal to x. To check it, write the original inequality. Take out your x and put in parentheses. Those little crooked parentheses inside there, waiting on a value that's less than or equal to 5. 5 is the greatest number the answer could be. And if it confuses you, rewrite that inequality so that it says x is less than or equal to 5, putting the variable on the left side. So the number I want to pick is 1, because definitely 1 is less than 5. So inside the parentheses, 10 minus 1 is 9. So I'll be left with 10 is less than or equal to 2 times 9. And 2 times 9 is 18. So 10 is less than or equal to 18, and that's a true statement, so it checks. Now you'll be able to look ahead, hopefully. Can you tell just by looking at these inequalities whether or not you'll have to flip them? So p minus 8 is greater than 9. To solve this one, all you'd have to do is add 8. There would be no flipping involved. This one, 1/5 x minus 2 is less than or equal to negative 10. So I'll add 2 and then divide by 1/5. So it's a positive 1/5. There'll be no need to flip. Okay, something went a little crazy there. Let's go ahead and answer this one. Alright, the second one, negative 4x minus 8 is less than or equal to 10. I'll have to add 8, but my last step will be dividing by a negative. So yes, I will flip. This one I'll have to distribute through by the negative 2, but I'll have a negative 2x plus 18 on the right side. It's the number that's with your x. Start looking for the coefficient of your variable, and this one will be negative, so I will have to flip. What about this one? Do you think you'll have to flip? This one's a no, because the coefficient with your x term is positive. What about this one? Yes, I will have to flip because of the negative 5. The coefficient with that c is really negative 1/5, even though you can't see the 1. So I'll be starting by adding 4, but in the end, I'll either have to divide by negative 1/5 or multiply by negative 5. So either condition is going to require me to flip the inequality. Alright guys, rewatch this if you need to. Come get help if you need to, but that was a lesson on solving inequalities.